Hey friends, welcome back to our YouTube channel Physics Zone. Today we will move ahead in our chapter of law of motion. Today we will discuss some examples for conservation of linear momentum. So, recoiling of gun. In recoiling of gun, we will consider mass of bullet. M1 is the mass of bullet, M2 is the mass of gun, V1 is the velocity of the bullet, V2 is the velocity of the recoil of gun. During recoiling of a gun, a bullet moves with the greater speed in forward direction. That time, due to some reaction force, the gun moves in backward direction to some distance. Okay. So, here according to law of conservation of momentum, we can say the linear momentum of the gun will be equal to linear momentum of the bullet. Okay, so from here if we say linear momentum of bullet is m1 v1, okay, and that will be equal to linear momentum of gun m2 v2. Okay, now but it will be in opposite direction, so negative sign. From here we can say v2 is equal to minus m1 v1 upon m2. So this is the velocity with which the gun will move backward when the bullet go forward with a greater speed. That time the speed of velocity of gun will be minus m1 v1 upon m2. Okay. So from here we can say v2 is inversely proportional to mass of the gun. That's why the gun is made up of heavy mass, means it must be much greater than the mass of the bullet, so that's its velocity in backward direction can be minimized. Okay, and that's the reason why soldiers are advised to attach the gun with their soldiers, so that the total mass can be increased and the velocity in backward direction can be decreased. Okay, now one more statement is second law is the real law of motion. Second law is the real law. Why it is said? It is said because first law and third law both are contained in second law. Okay, we can see how these are contained. So let's consider we know F is equal to ma. We have taken F is equal to 0, means no external force is exerted on it. Then ma equal to 0. And we know if a body is in existence, it can't be massless. There will be something mass of the body, so m can't be equal to 0, so acceleration will be equal to 0. Okay, hence from here we can say if there is no external force, then the acceleration is 0. That is the first law. When no external force is applied on the body, there will be no change in its position of motion or rest. Means here, if there is no acceleration, there will be no change in the state of body. Okay. So here from here we can say first law is contained in second law. Okay. Now we can see how third law is contained in second law. Let's consider. So consider two bodies. Let's consider an isolated system of two bodies. Okay. Let A and B, two bodies in an isolated system. If they collide with each other, A and B collide with each other. Let A is exerted a force on B, that is F1. B is exerted a force on A, is F2. Okay. And this is exerted a force for del T1 time and this for del T2 time, means for a very short time period. Okay. Now from here we can find linear momentum. The linear momentum we know is F into time, means force into time. F is the force and del T1 is the time. It will be linear momentum for first body. So linear momentum for first body for body A, it will be F1 into del T1. Okay, this is the linear momentum for first body. And we know the linear momentum for first and second body, means the total linear momentum will be conserved. So plus linear momentum of second body F2 into del T2 is equal to 0. According to the law of conservation of linear momentum, we can say the linear momentum of the two bodies will be conserved. So the total linear momentum can be set as equal to 0. Okay. So now from here we can say F1 is equal to minus minus F2. Okay. We can see here there is no external forces exerted on the system of two bodies. So the linear momentum that was in initial condition will be equal to the linear momentum in final condition. Okay, so we have taken the total linear momentum equal to 0. Okay, so from here we have found that F1 is equal to minus F2. So we can say from here this is action and this is reaction, that is equal and opposite. Negative sign is here, that is showing its opposite. Okay, so from here we can say the third law is established from here. The action is equal and opposite to the reaction. Okay, so we can say third law is also contained in the second law of motion. Okay, hence proved. So from here we can say second law is the real law of motion. Okay, now we will discuss connected motion. In this we can consider two masses hanging on a pulley. How will they exert force, how tension will act on them, we will see all that in this. Okay, now consider, now we can say this is the pulley. Okay, this is the pulley. Two masses are hanging on this pulley. One is M1 and another is M2. The rope, this is the rope that is hanging with M1 mass. It is facing a tension T, and this is another mass that is hanging with this rope. This rope is facing a tension T also. Okay, from here we can see M1G. Here let's consider M1 is the greater mass than the M2. Okay, in that scenario acceleration of the mass will be downward. Okay, so from here we can say the total force that is exerting on downward direction, that will be MA, will be equal to M1G minus T. M1G is the force that is exerting in downward direction and T is the tension that is exerting in upward direction. So their resultant will be MA, because that is taking the mass in downward direction. Okay, so from here this is the equation. Okay, and now we can consider from this second mass M2, this mass is going in upward direction. Okay, so means when this mass is moving in downward direction, this mass is moving in upward direction. So the total resultant force that is exerting on this mass is in upward direction. So it was M1. So from here we can say M2A will be equal to, here tension force will be greater because the resultant is in upward direction. So tension minus M2G Okay, this is our second equation. Okay, now from first and second equation, from first equation we can write tension equal to m1g minus m1a. Okay, and from second equation we can write tension equal to m2a plus m2c. Okay, so from these two equations, this and this, tension is equal. Tension is same thing in both the equations. If this is equal to tension, this is equal to tension, and these both are equal, so we can say this quantity is equal to this quantity. Okay, so from here we can write m1z minus m1a equal to m2a plus m2c. Okay, so from here we can find acceleration. So m1z minus m2c equal to m1a plus m2a plus m1a. Okay, so from here acceleration can be find out m1g, sorry, not a task of sorry, upon m1 plus m2. This can be written as m1 minus m2 into c. J is common from here and divided by m1 plus m2. Okay, this is acceleration for in case of pulley. With how much acceleration this mass will come down. Okay, this is the acceleration. Okay, so now we can put in any equation and we can find tension from here. Tension is equal to, from second equation, from this equation we can, or from any of the equation we can write tension. Let's, from this equation tension is equal to m1g minus m1a, what we have find out, m1 minus m2 into c upon m1 plus m2. Okay, so solving it we can write tension equal to 2m1 m2 into c upon m1 plus m2. Okay, this was about connected motion. Okay, now we can discuss another topic, that is system with variable mass allocate. Okay, we will discuss it in another video. Okay, so thank you for watching my video and have a nice day.